Welcome to a lesson on conic sections. In the previous video we looked at circles and ellipses. This time we're going to look at hyperbolas. So particularly with hyperbolas we want to know, again, how do we graph them, how do we write them in standard equation, how do we figure out their characteristics, so their center, their vertices, their foci, major axes, and then hyperbolas have asymptotes that we're going to look at. So how do we figure out all this stuff? So let's first define what a hyperbola is. It's the set of all the points in the xy plane who the difference of their distances from two fixed points is constant. So remember, with ellipses it was the sum of their distances. Now we're looking at the difference in their distances. So if you looked at this length here from the first focus to a point on the curve, if you look at that distance and compare it to the distance from the same point to the other focus, the difference in this length minus that length will always be constant, no matter where the point's located, whether it's on one part of the hyperbola or the other part. Remember, with hyperbolas, that's where the plane intersected the two cones twice, and so we got two curves. If you want, you can play around with either of these little activities to kind of visualize what a hyperbola looks like a bit more. In general, hyperbolas are similar to ellipses. The equation looks very similar, but what you should notice right off the bat is there's a minus here instead of a plus, and because that's a minus, that produces two variations on the equation. So in the horizontal major axis, so if we have a horizontal hyperbola, so the graphs are opening to the left and to the right, this is going to be an x that's being squared. Okay, so it's x squared minus y squared equals 1. If it's a vertical major axis, so that means the two curves sort of open up and down, then it's a y squared minus an x squared equals 1. And again, I do this a little differently. Some texts will always put a with the positive variable, and I don't. I always let a go with x, b goes with y. And the reason I do that is because it makes a, just like with the ellipse, a is always the horizontal distance from the center to the left and from the center to the right. And whether it's horizontal or vertical, a is the horizontal distance from the center to the left and from the center to the right. B is always the vertical distance from the center up and the center down, from the center up and center down. And C is always the distance to the foci, so from the center to the foci and the center to the foci, whether it's horizontal or vertical. Notice this time, though, that again, the foci, the value of C is going to be larger than A or B, because the foci have to be outside. So in other words, the curve is always curving around. So this curve here is going around. It's bending around the foci, the right foci, and then this curve is bending around the left foci. So the curves will always sort of wrap around the foci. They pass through the vertex and curve around the foci. Okay. So if we have a horizontal hyperbola, we have x squared minus y squared. If we have a vertical hyperbola, vertical graphs, we have y squared minus x squared. A is always the horizontal distance, B is always the vertical distance. Okay. Notice also on the graphs here, there's these boxes, this little box here, so we'll talk about that here in a bit. And then we have these asymptotes, these diagonal lines. So notice that the diagonal lines pass through the center of both of our graphs, and they pass through the opposite corners of the box. That's one of the reasons we have the boxes. It helps us figure out where these diagonal asymptotes are going to be. The dimensions of this box, if A is the distance from the center to the left and the center to the right on either picture here, then the box has a width of 2A, and similarly it's going to have a height of 2B, because it's from the center up and the center down as B. The relationship between a's, b's, and c's is c squared equals a squared plus b squared. So it's very similar to what we had for ellipses, but this is now a plus here. And again, the things that we need to know is very similar to an ellipses: centers, foci, major and minor vertices. Really, it's just major vertices, and then we have a major axis as well. So let's look at an example where we're given a graph. So from the graph, we should be able to figure out hopefully where the center is located, which in this case it looks like it's at 2, -1. We can figure out where the vertices are. At least one of them here is labeled or marked out for us. So this vertex is at 5, -1. And then we have one of our foci, which over here is at -3, -1. So first, notice that all three of these points, and if we marked all the other vertex and the other foci, they are all at the same y-coordinate. They're all horizontally the same. If we flipped the graph and made it vertical, they would all be on the same x value. They'd all be lined up vertically. But here we have a horizontal ellipse. So again, the things that we should be able to pick up from the graph: where's the center, what's the value of a, b, and c, and that we should be able to determine that it's horizontal. Okay, because again, the curves open up to the left and to the right. Now a is 3 because that's the distance from the center to the vertex. That's 3 units apart. C is 5 because that's the distance from the center to the focus point, to the foci. So that's the distance of 5. B, we can't get off the graph because I don't know how tall, if we drew that box in here, I don't know how tall the box is. So in order to figure out B, we need the other two. So we're going to use c squared equals a squared plus b squared. We plug our a and our c value in there, and we solve this for b, and we get b is 4. Okay, so that's enough information for us to write the equation of the graph. So again, it's because this is a horizontal hyperbola, I know it's going to be the x squared fraction minus the y squared fraction. And it's going to be equal to 1. So we plug 2 in for h because that was our x coordinate of our center. We're going to plug a -1 in for the k. 1 minus a -1 becomes 1 plus 1. I know the a is 3 and the b is 4. And so we get x minus 2 squared over 9 minus y plus 1 squared over 16 is equal to 1. All right, so how do we graph a hyperbola? So the first thing we need to do is locate the center of the hyperbola. Just plot that point on the graph. We then need to use the values of a and b to sketch that box. So remember, a is the horizontal distance from the center to the left and right. B is the vertical distance from the center to the top and the bottom. Okay, so the box is going to be 2a wide and 2b tall. Once we get the box drawn, we can draw our asymptotes. Remember, they're diagonal lines. They go from opposite corner to opposite corner through the center of our box. We can then plot the major vertices. So if we have a horizontal hyperbola, the vertices are going to be on the left and the right side of the box. If it's a vertical hyperbola, it's going to be on the top and the bottom of the box. And then we can just sketch the two curves. They should go through the vertices and they should approach and kind of curve out towards the asymptotes. So let's try an example here. So this is given to us in standard form already, so we should be able to pick out some basic information right off the bat. We should be able to figure out that the center is -3, 1. We should be able to figure out that a is 5 because that's a goes with x and a squared is 25. B goes with the y, and so since it's a 16, b is 4. C is the one we don't know. We're not given that on the graph or the equation here. And because it's the y squared term first, because it's y minus x, I know this is going to be vertical because vertical is the y. All right, so those are things you should be able to just quickly tell right off the graph or right off the equation. In order to get to the graph and the foci and stuff, we need to figure out c, which we can use our c squared equals a squared plus b squared equation. We plug stuff in there and we get that c is equal to the square root of 41. Before we list out all the different components, we can go ahead and sketch the graph real quick. So we know the center is 3 units to the left and 1 unit up, so that's negative 3, 1. Because the A value is 5, I know from the center I can go 5 units left and 5 units right. So that's the width of our box is 10 units across. And because B is 4, I know I can go from the center 4 units up and 4 units down. So that gives us the top and the bottom of the box. So we draw our box. We then draw our diagonal lines through the corners of the box and the center. So we get 2 of those. So that gives us our 2 asymptotes. And then because this was a vertical hyperbola, I'm going to put the vertex on the top and the bottom of the box. And again, they should be vertically aligned with the center. And then I'm just going to draw the 2 curves. So it comes from one asymptote down through the vertex and up through the other asymptote. Same thing here, it comes along the asymptote, touches the vertex, and then goes back out the other asymptote. So that's what the graph looks like. And then from there we can list out all of our points. We know the vertices, again, they're going to be at the same x-coordinate as the center, so negative 3. But if we're going to go 4 units above, so 4 units plus 1 would be at 5, so negative 3, 5. 4 units below negative 3, 1 would be at negative 3, 3. So it's these 2 points here. The foci, again, the foci are actually going to be higher, and they're going to be inside the curvature here. So negative 3 and 1 plus the root 41, and then a negative 3 comma 1 minus square root of 41. And again, I'm adding those to the y variable, the y component of our point, because it is a vertical hyperbola. And again, I know it's vertical because it was the y squared minus the x squared. To find the asymptotes, all I'm really caring about right now is can you figure out what's the slope of them. And so slope is rise over run. If the rise is 4 units and the run is 5 units, then they have a slope of 4/5 and negative 4/5, which we could just express as plus or minus 4/5. All right, let's try one more here. So in this case, we're not given a graph, we're just given the location of the foci and the vertices. So let's go ahead and draw it. If we plot our points, we have plus or minus 10, and then plus or minus 8, which halfway in the middle of 8 and negative 8 is 0, so there's your center. Because all these points are lined up along the y-axis vertically, I know that this is going to be a hyperbola that opens up and opens down. So it's a vertical ellipse. And we know the center is at 0, 0. So again, things I can pick up off the graph real quick. The center is 0, 0. Don't know A, but we do know B is 8. That's the distance from the center up to the vertex. C is 10. That's the distance from the center to the foci. And as we've already said, it is a vertical ellipse. So in order to write the equation, we need to figure out A, which we can do that using c squared equals a squared plus b squared. We plug numbers in, simplify, we get a is equal to 6. So that's all we need. Because this was a vertical ellipse, I know it's going to be y squared first, then minus the x squared. We plug 0, 0 in for the h and the k, because that was our center. B is, in this case, is 8. So we get a y squared over 64 minus, and then a was a 6, so minus x squared over 36 is equal to 1. And if you want, you can practice some problems in the lab manual. Again, we already talked about this in the previous lesson, but if we had the equation in general form for the conic, as we already saw, if the a and c are equal to each other, we have a circle. If they are different values but the same sign, we have an ellipse. And now if they are opposite sign, we have a hyperbola. So let's look at an example where we're given the equation in general form. So we have x squared minus 9y squared. So because this is a positive x squared and a negative y squared, I know this has to be a hyperbola. So to work through this, we just have to complete the square again. So we're going to group the x's, we'll group the y's, and then we're going to take the 149 and move it to the right side. So we group the x's, group the y's, and move the 149 over. Notice with the y's we have a -9, so we're going to have to factor that -9 out front. And when you do that, you have to factor it out of both the y squared and the y term. So that means we have a -9 out front times the quantity of y squared plus an 8y. And then again, we have to figure out what numbers we're going to add to each of our variables. For the x's, we're going to take this 4 and divide it by 2, which is 2. And we square it, so 2 squared is 4. So we add a 4 here, and we're going to add a 4 on the right side as well. We're going to take half of the 8, which is 4, and square it, which is 16. So we're going to add a 16, but that 16, remember, is being multiplied by -9. So 16 into -9 is a -144. So I'm going to add a -144 on the right side. We simplify the right side, we factor the left side, and then we want the right side to equal 1. So we're going to divide everything by 9. So this is the equation that we get. From that, we should be able to, again, identify the center, which is at 2, -4. We should realize that A is 3, B is 1. C we don't know yet. And because it's the x squared minus the y squared, I should know that this is a horizontal hyperbola. We then need to find C, so we just use our equation again. C squared equals A squared plus B squared, and we get the square root of 10. And then if we plot our graph, again, we know our center is 2 units to the right and 4 units down. We know it's 3 units to the right, 3 units to the left. It's 1 unit up, it's 1 unit down. So that gives us our box. We draw our diagonal asymptotes, and then our vertices. Since this is horizontal, the vertices are on the left and the right side. We draw our curves, and that's our graph. And again, once we get the graph, it's pretty easy, hopefully, to label most of these, the characteristics of the graph. The vertices are going to be at -1, -4, and at 5, -4. Notice both the vertices and the center have the same y component, same y coordinate. For the foci, again, the foci have to be inside the curves, so they have to be on the same y coordinate as well. So they're going to have both -4 for the y coordinate. They are going to be a square root of 10 to the left and a square root of 10 to the right of our center. So 2 plus root 10 and 2 minus root 10. And then the asymptotes, their slopes again, it's 1 rise of 1 and a run of 3, so plus or minus 1/3.